So let's look at some characteristics of a redox reaction. In a redox reaction, there is a transfer of electrons. There's two processes that are occurring, oxidation and reduction. And as I mentioned in the last lesson, they occur hand in hand. So let's look at what oxidation means. Oxidation is the loss of electrons. Now, I know this sounds kind of backwards. You're losing something, but you're increasing in your oxidation number. But remember, electrons have a negative charge. So if you're losing negative particles, you're going to become more positive because there's going to be more protons than there are electrons. So there's an increase in your oxidation number for that element. Reduction is where you have a process of gaining electrons. So there's going to be a decrease in that element of the oxidation number. Because they're gaining negative particles, that one is going to get more negative. So to help you remember the definition, here's an acronym. LEO goes GR. LEO helps us to remember lose electrons means you oxidize. Leo would be the lion. Leo the lion goes GR, and like he's growling at you. GR is gain electrons means you reduce. GER. Another way that I've seen this explained, or another mnemonic device for this, is oil rig. Oxidation is loss. Reduction is gain. And of course, they're talking about electrons there. So that's another way to remember it. Two other terms we need to be familiar with are the reducing agent and the oxidizing agent. The reducing agent is the reactant in the redox reaction that loses electrons. It is the agent that causes or enables the reduction to occur. So in the process of it losing electrons, it is enabling the other substance to reduce, because it's kind of like they're tag teaming. They're working together. One thing's losing electrons while the other thing is gaining. So the reducing agent is whatever reactant was present in the reaction that actually lost electrons. Oxidizing agent is the reactant that gains electrons. So in the process of gaining electrons, it's causing or enabling the opposite process to occur, oxidation. Now this can be a little confusing, so here's kind of another way to help you remember, another mnemonic device to help you remember. RA, reducing agent, LEO, Leos, the reducing agent Leos. So if you look at that, I know it's not really a word, but think about our capital of North Carolina, Raleigh. So Raleigh helps us remember the reducing agent loses electrons, and in the process, it oxidizes. So Raleigh. For oxidizing agent, I know this is not how you would spell ogre, like Shrek was an ogre, but it looks like if you were to phonetically say that, ogre. Okay, so oxidizing agent gains electrons and reduces, OAGER. Oxidizing agent gains electrons and reduces. So let's practice an example of assigning oxidation numbers, identifying the substance oxidized and the substance reduced. First thing you got to do is go individually to the compounds and assign oxidation numbers. Keep in mind, if it's a compound, a neutral compound, the sum of the oxidation numbers is 0. And if it's an element in its elemental form, its oxidation number is 0. In this process here, let me mention too that the coefficients are not going to affect, you're going to do just for oxygen, one oxygen and one CH4 for the carbon and the hydrogen. And then you do the same thing for your products. This is a compound, so the sum of the oxidation numbers have to equal 0 here. And this is a compound, the sum of the oxidation numbers have to equal 0 here. So let's start. Carbon does not have a rule, but hydrogen does. And hydrogen, in this case, is going to be a positive 1 because he's less electronegative than carbon. So 4 times a positive 1 gives you a plus 4 overall. So that means in this case, since there's only one carbon, that he's a minus 4. So his oxidation number is a minus 4. So on this side, carbon is a minus 4. Hydrogen is a plus 1. Now the other element on the reactant side that we have is oxygen. So let's Write down what he is. Oxygen is in its elemental form, and so the rule for an element in its elemental form is his oxidation number is 0 because it's neutral. Now let's look over here. In this reaction, what's happening is electrons are being transferred. So we're keeping track of electrons here. So let's assign the oxidation numbers that are in our products here. So oxygen has a rule again. In most compounds, he's a -2. So we have 2 times a -2 is a -4. And there's only one carbon here, so carbon's a +4. So carbon on this side is a +4. Oxygen here is a -2. We also have hydrogen here. And you're going to see in this compound, oxygen stays a -2. So on this side, he's a -2 in both cases, so you just write it one time. So -2 for the one oxygen, and so that's a -2. And then hydrogen, since there's 2 of them, they've together got to give you a total +2 to make this equal 0. So that means individually they're +1 apiece because 2 times a +1 is a +2. So in this case, hydrogen is a +1. All right, so let me change color of ink here. So now let's take a look at how we would go through the process of answering the question. So carbon goes from a -4 to a +4. So this is what he changed. He was a -4 on this side, +4 on this side. So the only way, if you think of it in terms of either gaining or losing electrons, that he would go from a negative to a positive is he had to do what with his electrons? Think about it for a moment. He would have to, with his electrons, have lost them. So he lost electrons. So he LEO'd. Hydrogen, here's hydrogen here and here. Notice hydrogen is the same. So it's kind of like a little spectator. It doesn't undergo an oxidation. It's not involved in this particular oxidation reaction. Now look at your oxygen. Oxygen went from a 0 to a -2. On this side is a 0, on this side is a -2. So his oxidation number got more negative. So what he did is he gained electrons. So think of GER. Gain electrons means you reduce. So now that we figured out who LEO'd and who GER'd, who lost electrons and who gained electrons, think about in terms of RALEO and OGER. We got to make this spell, one of them has got to spell RALEO and one's got to spell OGER. So R-A, RALEO, OGER, OGER. So here's the key. Now, we've assigned oxidation numbers. The substance reduced. So the substance reduced was the oxygen. The substance that's oxidized, lose electrons oxidized, was the carbon. Now, the agents, the reducing agent and the oxidizing agent, their reactants are the entire reactant. So, RALEO, the reactant that contained carbon, is the one that was the reducing agent. So come back to your reactants and find the carbon. That means the CH4 is your reducing agent. OGER, the oxidizing agent, is the reactant that gained electrons and reduced. So look at your reactants and find the thing that had oxygen. So it's just oxygen. And that's going to be the reactant that was your oxidizing agent. So substance reduced is oxygen. The element that's oxidized is carbon. The reducing agent is the reactant that contained the carbon, so CH4. The oxidizing agent is the reactant that contained the oxygen, which is the molecular oxygen. Okay, I'll let you try this one on your own. I'm going to go ahead and, for time purposes, assign oxidation numbers, 0 and 0. They're both in their elemental form. This is a compound. It's got to add up to 0. -1 for iodine gives you a -3 total, so that means aluminum is a +3. There's only one aluminum. Okay, so aluminum and iodine are the only substances involved here. So on this side, aluminum is a 0 and he goes to a +3. On this side, oxygen is a 0 and he goes to a -1. So this one lost electrons and oxidized. This one gained electrons and reduced. So the substance that LEO'd, that oxidized, was aluminum. The substance